In previous episodes, we started building a Kanban board with cards organized in columns. In this episode, we'll provide the finishing touches. You'll learn about element keys and why they matter for performance, and also how to use React's lifecycle methods like component.did_mount when you're using Reagent. As usual, all the code is on GitHub, so if you didn't follow along with the previous episode, just grab it from there and check out the right branch. You can find the link and instructions in the show notes. Now open the app in the browser and have a look at the console, because both React and Reagent are trying to tell us something. When there are multiple columns on a board or multiple cards in a column, then React wants you to give each of these a key property. So let's give each child element of this column div a key. Keys only need to be unique among siblings, and since we'll only ever have one of these input and h2 elements in each column, we can just give them a hard-coded string. For the card, I'm using the index number. Notice now that for card and for new card, we're passing properties to the component, so we need to update the component signature. Now maybe you were already using a map of properties as a first argument to your components, the way you would do in React, and in that case it makes sense to put the key in there. But so far we've been using positional arguments, which is something Reagent lets you do. So in that case, there's another way to specify this key using metadata. Clojure and ClojureScript both allow you to specify metadata with this caret notation, and this map of information gets attached to the following value, but it doesn't change the value. Now Reagent will find that key in the metadata and use it. So I'll update all the places where we were using keys already, and I'll also add them to columns, because we were getting warnings for that as well. And now have a look at your browser, and the warnings are gone. To understand why React wants us to add these keys, we need to look at how React updates the DOM. Suppose we have a div containing two card elements, and now we add a third. So the current browser DOM contains the two cards, and our newly computed virtual DOM contains three. To figure out what needs to happen, React will scan these lists of children from left to right. So it looks at the first one, and those are still the same. It looks at the second one, those also haven't changed, but the third one is new, so React knows it needs to add it to the DOM. Now suppose we add a card in the middle of the list. React looks at the first one and realizes it's the same, but now it looks at the second one and it thinks it's changed, whereas really it's just changed position. And now it looks at the third one and it's going to add that one as well, where it was already there. So you see that React is now doing more work than it should. If we give React these keys, then it can figure out when an element just changed position, and instead of redrawing everything, it can simply move it in the DOM. Now if you think about it, our current approach isn't that great. As a key for each card and column, we've been using its index, but if a card or column changes position, its index will also change. So we need something that doesn't change, like a database ID. Now currently our objects don't have IDs, but we'll just add random ones. Now I'll replace this for loop with map indexed, because not only do we need the index, but we also need the card itself to pull out the ID. This whole let block doesn't really change, goes in there. And then as a key, we'll use the ID. And this can actually be even more concise with some destructuring. Now this for loop can go. And now we'll do the same for the columns. So map indexed, so I can get both the positional index and the column itself. I still need this index because I need to build up this cursor. That whole thing moves in there. For loop goes. And then I destructure the ID out of the column, use that as a key, and there we are. Let's start wrapping things up. There are still three things missing: adding new cards, adding new columns, and editing column titles. We'll start with adding new cards. This should start looking familiar. We first need a function which will handle the event. This addNewCart function takes a column cursor and then updates it by adding a new cart to the carts list. Make sure a cart also has a unique new ID, and then it has an empty title, and we already set its editing flag to true, so you can start typing right away. Now the new cart component needs access to that column cursor so it can update it. And let's see if that works. No, it doesn't because we still need the onClick handler. So call addNewCart, pass it to column cursor, and that looks better. Adding a new column is very similar to adding a new cart, but I'll implement it in the other direction now, starting from the parent component. So I'm passing this board atom to the new column component so that we can update it, and then adding an onClick handler, which calls an addNewColumn function. This one hasn't been implemented yet, but I can use CLJ refactors from example functionality to generate it for me. And then this addNewColumn function updates the board by adding a new column to the list of columns. And a new column is a map containing a new random ID. It has an empty title, but we can edit that straight away, and then it has an empty list of carts. So that's it. Let's see if that works. This looks a bit funny. Yeah, because these event handlers need to be in a properties map. And now it works. Yeah, we can't edit the title yet, but we'll get to that in a second. Editing a column title is going to be very similar to editing a cart. You want to be able to click on it, then you get a text field, type some text. When it loses focus, it stops editing, or when you press enter. So all that behavior we should be able to reuse from our cart component. Now, I'm going to change this cart component into a generic editable component. Now it just takes a cursor instead of a cart cursor because it's no longer specific whether it's a cart or a column. Both have a title and an editing flag, so it should be able to just use either. Now, the only thing that's going to be different is this element type. Before it was a div with a class of cart. That's going to be different for columns, so I'm going to pass that in as an argument. And then, yeah, before we were setting this editing class name with hiccup syntax, but now I'm just going to add it as a React property. And now I can make a new cart component, which just uses this editable component, and that still works exactly the same. And now we can use that editable component in the column. We already had a little bit of code in there to deal with the editing flag, but that can all go. Instead, we're just going to put the title inside this editable. Yeah, make sure it still has a key because it has siblings. Does that work? No, we're getting a blank page because it needs to take the cursor. And let's see, click on that. Cool, and now we can edit column titles. Good job, so our app is pretty much finished. So the app's finished, and we're all drinking White Russians in the pub to celebrate the big launch. And then suddenly the head of QA calls. Turns out that this auto-focusing of the input fields doesn't really work on iPhone. And this truly will not stand, man. So now it's up to you. You can choose your own adventure. Do you A. slap on a polyfill for autofocus, or B. decide to get your hands dirty with the DOM? If you chose A, you can stop the episode now and go bowling. But if you chose B, you're going to learn something new, so stay put. Now, first we need to talk a bit about Reagent components again, because they come in 3 flavors, known as Form 1, Form 2, and Form 3. So far we've only used the simplest of these, the Form 1 components, which is just a function returning hiccup. Form 2 components are very similar, but instead of returning hiccup directly, they return a function which then returns hiccup. This inner function takes the exact same arguments as the component itself. With this kind of component, Reagent is going to call the outer function only once, and then afterwards always use the inner function to re-render the component. So you can use the outer function to do one-time initialization and setup. You can also use this to create component local state by closing over a Reagent atom. Of course, the usual caveats apply about component local state, so avoid it except for the smallest and simplest of cases. So Form 1 and Form 2 components are just functions. That's simple enough. But if you watched the React episode, you might remember that in React to create components, we used this function called createClass. And that gave us a place to put React Lifecycle methods. Now, Reagent has the same thing. So in the Reagent core namespace, you can call createClass and then pass it similarly a map of lifecycle methods. Notice though that instead of just calling render, in this case we need to call it reagent render. Otherwise, your updates based on reagent atoms might not happen as you expect. We haven't talked much yet about these React lifecycle methods, but they're core to leveraging the full power of React. So we'll see a first example now. We're going to build a component that works just like regular input field, but it also autofocuses itself. So I'm using this reagent create class now, and in my render method, I'm simply rendering an input field, delegating the properties that I received. So now in this editable component, I can use that instead of the input field. And I'm going to take this autofocus out because we're going to implement that in a different way. Now we'll add this component.didMount lifecycle method. This method is called when React is done rendering the component and attaching it to the browser DOM. So now we have an actual DOM node to work with. Now this method receives the component instance as its argument, and then we can use this reagent function to get the actual DOM node that corresponds with this component, and then this will be the input DOM node, so it has a .focus method which we can call to focus it. So that's it. In these few episodes, you build a fully functional Kanban board using Reagent. We built the UI with Reagent's components and event handlers, and manage the state with Reagent's atoms and cursors. Now, when you get to more complex applications, there are other ways to approaching your state, because cursors mean that your application is still quite tightly tied to your global application state. But nevertheless, cursors are a great tool to have in your toolbox, so it's a good starting point. I hope you enjoyed this episode. I don't know if you noticed, but starting this episode, I'm changing the process of how I do my recordings, which I hope will result in better pacing, better narration, and also a more smooth viewing experience. So let me know what you think about it. You can leave a comment below this video. You can reach out on Twitter. I'm at Plexus or at Lambda Island. There's also a Clojurian Slack channel, #Lambda Island. Or just send an email, arne@lambdaisland.com, and I promise no matter which channel you use, I'll get back to you very soon. So that's it. Have a nice day.